All right, recording. Actually, 1 second. Just gonna. Okay. All right. So today we're going to be going over Node and Express. It's going to be an introduction into backend development. So everything that we've been doing so far with React, that's all client-side development. Again, client-side development, that's all of the code that gets sent down to your browser. So if we look on my browser, 1 second, I'm trying to figure out how to get this thing to go away. Oh, geez. Okay. All right, I'll play around with that a little bit more. Okay, but yeah, so if I go to twitter.com, then what happens is my computer, it sends a message out over the internet, and it goes and finds one of Twitter's domain, one of its, finds a domain name server. So we give it the name, and it gives us an IP address for a computer that our computer needs to talk to. And one of Twitter's servers is going to send us back some information to our computer. It's going to send us back some HTML, some CSS, some JavaScript, and that's what this page is going to be built with. So all those files get sent back over the internet, and then our browser reads those files, reads that code, and then it builds the web page locally based on the code that it received. So the reason that our web pages are all built in code that way is that's the format that we can easily transfer over the internet. So the code gets sent down to our machine, gets rendered and built into this all the stuff that you see here. So if we go to sources, you can see in here that it has a bunch of different these are different files and different things that were received from Twitter's servers. They sent us down a bunch of stuff. And, sometimes, with websites like Twitter that are so widely accessed, some of their basic files will be cached in lots of different places. And so, the actual Twitter HTML and CSS and JavaScript files will be cached in different servers all around the world. So that way you have faster load times, so the page will load quicker. But for smaller companies that maybe don't do caching or they don't really know what they're doing, or it's structured in, kind of an old way, they may not have that same kind of caching enabled. But yes, that's what's happening. So our browser is making an HTTP request, and that's it's just a request that shoots out over the internet, and then their computer responds back and gives us some files, gives us a bunch of different files, gives us some pictures, things like that, so we can manage this page. So that happens on load, and then as we so let's go to Wikipedia. So that happens on load, and then like if I were to type in a query, so like Samurai, so I type something in here into this form, then I hit the request button, then a message is going to shoot out, again to their server saying that this computer at this location is requesting, the information that's specified at this URL. So they want /samurai. So on their server, they're going to look at /samurai, grab the corresponding data from their database and send it back over the internet to our browser, which then the code locally runs it all here. So React is code 100% that's running in the browser. It's stuff that's on the client side. Today we're going to go over Node and Express, which are some tools that we use to write the stuff that's on the back end, the server code. This is the code that listens for these incoming requests. It's they're both applications. So like this is a client-side application, and then there's server-side applications. It's a computer program. They're both listening for inputs. The client application is listening for user input. It's listening for us to click on things. It's listening for us to, type in things. If you're on Facebook, it, is waiting for us to like different things or, make comments, things like that. And as it detects that input, then it sends a message off to the server. The server is just listening and it's waiting to receive requests that come in from different places on the internet. So it just sits there and it waits and it listens. And then when it receives a request, it processes the request. And then it takes the answer, the response, and sends it back to the location that it came from. So here's kind of a diagram of how it works. So ignore like the specific little numbers. Well, actually, I'm going to try something that I just noticed on this hat. Okay, cool. So, all right, so I'm drawing with a touchpad. So no guarantees for how awesome this will be. All right, okay, so this is a laptop. All right, great. And then we have our browser window that's open. You know, with your, you know, there's your Twitter feed that you're looking at. Okay, so all right, so there's the client. So, you know, you type your message. The message gets sent out to one of Twitter's servers. Okay, which is just a computer. It doesn't have a monitor. It's just, they just have these massive computers in a room that are connected to the internet. They receive these different requests, process them, send it back. So the server code, it will actually be separate from the database. And so the database is usually represented by these little circle things. All right, that's pretty terrible. Okay, so this right here is the database. All right, so then the server will talk to the database. The database is kind of like, if you think about it on your computer, you have like your hard drive that it actually saves the information to where it persists between power cycles. So your computer turns off, it turns back on, the information is still there. On your server, you have this code that's up and running. So if the server crashes and goes down, any information that isn't saved, so to speak, or saved to a database will be lost. And so the database is for permanent storage. So the power can turn off and then turn back on again, and the data is still there. This is like your Facebook profile info. It's still going to exist even if the server turns on and off. Whereas the server code, that's going to be reset multiple times a day. There's going to be tons of different server instances, different servers around the world that are all running the same code, that are communicating with all the different clients that are talking to them. So this is all just code that's running on the computer. Whereas this is actually, the database is actually the actual data that's living. So let me check. Okay. Okay, great. All right, so Austin's clearing that up. Yeah, so that's, those are kind of the three basic parts to a full stack application. You have the database stuff, the long-term persistence of data. You have the server, which is this is where Node and Express is. So, our Node and then our Express code are going to be, I'm going to get a stylus or something to make this a little better. But so Node and Express are code that's going to be running here. When the browser restarts, all the state, any information that's here is lost unless it was saved to the database. All right, Austin raised his hand.
Hey, so basically, if I understand this right, we've got the client, and React is kind of on the left side, and then Node is in the middle, and then on the right, so React that runs entirely on the client, right? That's entirely on my laptop?
Yes, yep. So the React code is running entirely on your laptop. So that comes down in the form of JavaScript files, with HTML and CSS files, and then the browser renders that. So all the React you guys have been working on for the past couple weeks, that's all stuff that's purely running on the client. It's not running on the server. And then, so the database, this is when you hear of things like MySQL or MySQL or MongoDB, Postgres. There's tons and tons of different kinds of databases, and they're all structured differently. A database, you can kind of think of it as like a spreadsheet. So if you think of so if you just think of like an Excel spreadsheet, and there's like rows and columns, that's kind of how the database is structured. It's just you have different columns and then rows of data. So like a user on Facebook, so when you would sign up, you would send. So yeah, so let's think of Facebook as an example. So you go to facebook.com on your browser. So then we send a message to Facebook's server requesting the code. So then they send back the code to then build the browser locally, so or build their web page locally using React. They use React, so all the React code and everything gets rendered. You see your sign up form, so you fill up your sign up form. You add your name, your email, password, everything like that. You click submit, and then that information gets sent back to the server. And then we say, and the server, we send it to the part of the server that knows, okay, we need to create a new user from the information we've received. The server then takes that information, parses it, and it sends it over to the database to save it. And the database responds, saved. And the server sends a message back and says, saved, successfully created. And then it redirects you to the next, like your home page. So then you can start editing more information. So that's kind of that basic flow. Let's say if you like someone's post on the Facebook feed, like you like it. So, you've already downloaded all that information onto your browser. Well, okay. So you go to facebook.com, Facebook sends you back the information, like to fill up the news feed. You see something you like, you click the like button, a message then gets sent to the server saying that user X liked user Y's post. So then the server goes over and then it says update it in the database that user Y's post with this ID just got liked by user X, and it saves all that information into the database. And then the database sends a response, says saved and updated. Now the server sends a response back to the client saying everything was updated properly. That whole process is happening every single time you like something, every single time you click the little heart icon on Twitter. Whenever you make a post on Facebook, it's constantly sending these messages back and forth, and it's going super, super, super fast. They're even using optic cables, the speed of light going across, oceans and things like that. So, these are really, really fast communication or signals that are being sent, but there's a lot of this back and forth communication that's going on. So, to build any sort of meaningful application now, you're going to have to start building out this client-server interaction. If it's just a static web page, when you hear the term static web page, that's a web page that you get in your browser that doesn't need to talk to the server, talk to a server. This is stuff like your local your high school's page for like their stuff that's coming up in the year. There's, maybe they don't have any type of login or they don't have anything, too sophisticated. It's just, here's a bunch of, it's just like a calendar page, or like, the lady that lives down the street has a little bakery out of her house, and she has a little menu up on their site, something like that. The local Thai restaurant, will have their menu up on a web page, but it's nothing special. There's no user interaction. So those are static web pages. There's no, it doesn't require this server really. All that needs to come back is just a server that just sends the HTML, CSS, and JavaScript files. There isn't this like constant back and forth communication between the client and the server like there is with Facebook or there is with Twitter or some of those more complex applications where, you push a button to like something and you have to send it to the server, or you keep scrolling on your infinite feed. And so the web page has to send a message to the server to get, more feed items to then get back to you. So, so most, applications out there and all the meaningful applications, they have this, client server interaction that's going on. So, so that's where Node and Express comes in. So what Node is an attempt to capitalize on the popularity of JavaScript. And so JavaScript is the only programming language that's used in the browser. There's HTML, CSS, JavaScript. That's it. There are some ways now to kind of, make other things work a little bit, but just basically you can just think there's HTML, CSS, and JavaScript in the browser. And so tons and tons of front-end developers are all learning how to use JavaScript. And so what some people did is they took JavaScript and they made it into a server language, a language that can run on the server. So JavaScript, so if you have JavaScript here, so Chrome, for example, this Chrome browser is built using C++. So your JavaScript code is read by a C++ program, and all these different languages keep getting compiled down and broken down until eventually they're ones and zeros that are interacting with the hardware on your computer. So you have different languages that are kind of built on top of each other, different layers of abstraction. And so JavaScript is a common language that a lot of people know, and it's a little simpler and easier to pick up and learn. And so your JavaScript code that's going in the browser is actually JavaScript code that's being run by C++ code, and then that C++ code by the computer is getting machine language and then binary eventually. There's a couple different programming languages in between these steps, but it's anyway. There's a bunch of different layers there, and so ultimately, your JavaScript code is controlling a C++ application. So what they did on Node was they added some additions to the C++. It's called the V8 engine. So this is called the V8 engine, and this is developed by Chrome. So the V8 engine is written in C++, and it reads JavaScript and then communicates with the computer at a low level. Because ultimately, your HTML, CSS, and JavaScript have to change the pixels on your monitor. And so that JavaScript code has to be turned into the ones and zeros hardware signal that's changing that one tiny little pixel on your computer screen. And that's your JavaScript code. From looking at your JavaScript code, obviously you're not controlling the pixels. You're not controlling, the specific like memory allocation and things like that with your computer. It's pretty high level. And so your HTML, CSS, JavaScript, they get, converted into different, they're being read by different languages and keep going down the stack. But yeah, so the V8 engine is the C++ language engine developed by Google that is really popular for processing JavaScript. So they use V8 on with Node, and what happens is essentially it's kind of like the Chrome browser V8, but then they've added a couple different features to it. So they've expanded on it. So it's an expanded version of V8 that can handle some different things that are important that you need in servers. So some of those things that you need in servers, you need to be able to write to files. You need to be able to listen on ports on a computer to be able to handle HTTP requests, streaming and different things like that. There's, I don't want to go into those specific details right now, but just there's a bunch of different things they had to add to this V8 engine in order to make JavaScript work as a server language, but they did, and it's actually pretty powerful. As for like handling lots of different simultaneous connections, Node is actually one of the fastest server-side languages, or runtimes that you can use. And so there's actually a lot of benefits to it, and it's pretty powerful. So Node is that expanded V8 engine. So when in the JavaScript mini bootcamp, if you did that, when I sent you those JavaScript problems and you ran them on your computer, you had to download Node. And so Node is a C++ application on your computer that reads the JavaScript in a way that your computer understands, and then can interact with your computer and print out stuff to the console, and it can run it inside of your terminal or console without needing a browser. So it allows your JavaScript code to exist outside of the browser. So that's what Node is doing. That's why you had to install Node. So Express is a library. It's a tool, kind of like React is built on top of JavaScript. Express is a library that you use in Node that makes it really easy to build out a server, to write your server code. So it simplifies it. There's a lot less code that you have to write. It just makes it a lot easier. So Express is to Node as React is to JavaScript. So it's just kind of this, Express is just JavaScript code. It's just a JavaScript library that makes it really easy to do the stuff that Node, natively or inherently does. So yeah, so that's what's going on there. So pretty cool stuff. So it makes it so someone like you can learn JavaScript, and then by mastering that one language, you can go in and you can write your JavaScript code in the browser. You can write JavaScript code on the server, interact with databases and things like that. And eventually we get into React Native. In our part-time and full-time classes, we go through React Native, and that's where instead of this browser, we have we have your, your mobile phone here, whatever, that can communicate with the server and back and forth. So yeah, that's kind of this full stack application architecture. That's all the different moving parts and the things that are going on here. So yeah, so let's dive in and write some Node code. See a question. Design in the PT course. Such beautiful art. Yes, I will personally be teaching you all of the design and graphic artists stuff. No, we'll be having someone else do that. So, all right, great. So let's now jump in to some Express stuff. See another question. All right, great. Okay, so I had a little server up that I was playing with earlier. I'm going to go out and nuke it. Okay, zoom in. All right. Actually, you know what? I'm going to make sure that this is doing HD by default. Hey, everyone. Enable HD video. Great. All right. So how much design does a developer need to know? It really depends. If you're doing tons of freelance work, then it's like, I mean, if you're doing everything, then it would be important for you to learn it. If you're part of a larger company, like they usually have designers, like designated designers that will make all of your mockups and everything. So generally as like a front-end developer, what would happen is that you would get this Photoshop document that it would just be a picture of what they want the page to look like. And then you take that picture and turn it into code. And so I've never had to know like really great design. I mean, I've done some freelance projects where I've had to kind of, whip some things together. But usually I just go and find other web pages that I like and then kind of copy their styling. The other, yeah, and or if you have friends that are good designers. We don't really dive into a lot of design in our upcoming course. We go over design in the sense of like how to structure your application in a way that is good for your user. So just like good user flow, or what features are really good to have, just like that user experience design. We don't go into Photoshop and kind of that artistic design at all. I mean, we may add something in. I've just been having my mouse sit here while I've been talking. So yeah. So anyway, that's what we're going to be going into. All right. So let's do some Express stuff. All right, so I just have an empty folder here, and then I'm going to create a new folder called server. All right, there it is. I'm going to go into it. All right, so see it's empty. So now I'm going to go npm init. So this is going to create a package.json file. I'm just going to hit enter and go through it because I don't really care too much about the actual description inside of the JSON file. I just need a package.json file to handle when I do npm install. All right, so there it is. Okay, so now I'm going to go npm install --save makes it better Express. I already have Node installed on my machine, but if you don't have it, then that's something that you'll have to do. Oh, come on. Okay, sometimes it gets hung up and you just have to kill it. And if it takes more than like 2 seconds to install a package, then usually there's something got like messed up in the install process. So, all right, so now if we go clear ls, you can see there's the contents. I'm going to open this up in Sublime. All right, so here's our package.json file. You can pretty much just ignore all that for right now. But here, dependencies, you have Express. So there's Express, there are Node modules. You never, ever need to look in Node modules. That's all handled by the stuff that's here in package.json. If you need to change something in Node modules, update your package.json, delete the Node modules folder, and reinstall it. You should never be touching the code in here. That's all just automatically managed by what you have inside of your package.json file. So yeah, just rule of thumb, you never need to touch Node modules. All right, So let's do, okay, so I'm going to create a file called server.js. All right, so if I needed to reinstall node modules, what I can do, so let's say I remove it. So let's say that like I wanted to update Express. So it's like I wanted to be on 0.3 now, or I wanted to be, you know, on version 5. And so I go in and change that. Then what I would do is I would delete node modules and then run npm install again. So, so I'll just remove node modules, and then now I just go npm I or npm install, and then it's going to read the package.json file, grab all the stuff that Express needs, and install it. So you can see here that Express is the only thing that I've required. It's the only thing that I have in my package.json, but Express is built with a whole bunch of other npm modules. So it's going to go and grab all these other npm modules and install them, because Express is a pretty big project and it needs all these other tools. This is actually, we're discovering now, is a pretty, this is a way for security vulnerabilities to kind of sneak into your application, because sometimes, like, you know, you're just installing Express, but maybe Express wasn't too careful and they have some module on there that they're bringing in that has some type of security vulnerability. Anyway, that's kind of a newer thing that's becoming more kind of like widespread or common knowledge recently, is just this idea that, you know, little dangerous things can sometimes slip in, but don't worry about it for what you're doing at all right now. So, all right, so now we're back to original state. So yeah, let's go to our server.js file. So one of the things that is added in a Node, that Node adds to the JavaScript language, you know, if you remember, Node is, it's like an expansion, it's an expanded version of the V8 engine. So one of the features that they added was require. So this is so require is a built-in JavaScript keyword now. You can't use that in the browser unless you have other libraries that support it, that add it to JavaScript. But just by itself, they don't have require. So what we can do is now we're going to go var express gets require express. So I'm actually going to put this down a little bit. All right, and as you can see here, I'm using var. Let me just, actually just real quick, let me just do console.log hello world. All right, so I'm just gonna log that out. Let's go to terminal. So my server.js file, I can now type node server.js. And then you see hello world gets printed. So when I type in the keyword node, and then the name of the file, and then the computer will run the file, it will run all the JavaScript code. Any console log that's in there will log it out to the console here. So let me actually, node-v, let me go, sorry, this is just, don't worry about any of this for just a second. All right, so different versions of Node. For different projects I work on, I have to support different versions of Node. So I was just switching to a newer version of Node. And I think that in this newest version, I'm just going to test this real quick. I think it actually supports a lot of these ES6 features just natively, like right out of the box. So let's now run node server.js. And it works. Okay, great. All right, so const it is. All right, older versions of Node don't support it, so I'm just switching up to a newer version so we can do that. All right, great. So here is our, so express, so const express, require express. It's kind of like in React, like ES6, like when we did, you know, import React from React. Very similar, it's just kind of backwards a little bit. So we're just saying like, this variable express is equal to require express. This is kind of like from React. So it's kind of, yeah, so it's doing essentially the same thing. If we just put express like this, it's going to look in the node modules folder. If we did /, it would look for a file on this level called express.js, just like in React. This is going to look for the React module. If I go like this, it's going to look for a file named React on the same level. Okay, and again, because this is all JavaScript, it just assumes that there's a .js extension on it. So you can just, if you leave off JS, then it just assumes grab a JavaScript file. Okay, so again, yes, I mean, on here, you know, if we did, you know, we could have all sorts of stuff, you know, for let I get 0, I less than, or equal to 10, I plus, console.log I. So now we can go back to the terminal, run it. You see, well, test isn't defined. That was just something that I'd written. But you see that, you know, it runs through all the logic normally, prints things out, you know, so it behaves just, you know, the same way, the way that you would expect. Just instead of writing it in the browser, we're running it on our computer. Okay. So now what we're going to do is we're going to declare a, or we're going to create our server. So if you go to Chrome, so like in your browser and go to expressjs.com, this is where the API reference and everything is on here. This is where just, yeah, all the stuff is for like learning how to do it and like a reference. And so this like Hello World example is a good little reference for learning how to you know, set up your, you know, your initial application. So I actually reference it too, because most of the server code I write is not me setting up new servers, it's expanding and adding on to existing servers. So express is a constructor function, so we invoke it, and then we can pass in some different arguments to affect what app will look like. But anyway, this sends us back, it creates an object, so this function creates and then returns an object. So app is now this object, it's our server object. And then we can build different routes off of it. I'll go into that in just a second. But right now, we're just going to set it up to listen on a port on our computer. Let's go out.listen, 5000, and then we'll pass it a callback function. Okay, so I'm seeing some, all right, looks like there are maybe some connection issues. Maybe it's because when I switch to HD, that might be slowing it down a little bit. Let me just disable HD video, actually. Okay, hopefully that'll kind of speed it up a little bit. All right, so, all right, app listening on port 5000. Great. So we import Express, and we use Express to make this object. Object has a listen method on it. First argument we pass it is an integer that specifies the port that we want this app to listen on. We haven't done anything meaningful with it yet, so if you're kind of confused about what's going on, don't worry about it yet. All right, so let's run node server.js. Let's see, app listening on port 5000, which that is the message that I printed out here. Okay, so now let's specify our first route. So we can go app.get. So a GET request is when someone sends a message to our server and they're wanting to get something. So this is saying that, okay, the client or the person making the request, they want to get something. And then what they're going to pass in is they're going to pass in a route, a path. And so we're saying when someone sends us a GET request, so they want to get information, and they send it to this URL, then this is the information that we're going to send back to them. So we pass in a callback function, and which takes two arguments, or we specify two parameters, request and response. And then we're going to say res.send hello world. Okay, so there's different types of requests. There's get, and there's post, and put, and delete, and some others. Those are the main four. But anyway, we're just focusing on get right now. So we're saying that the client, when they make a request to just this base URL, then we're going to send them back this string hello world. So the way we can test a get request, is let's just go to Chrome. We can go to localhost 5,000. You can see I have these different things in here, but localhost 5,000. And when I go there, I have to have my server running. So the server, you have to restart it unless you use a thing called nodemon. And so if you go npm install -g nodemon, then what that does is it installs this program onto your computer that allows you to set up your allows us to set up your server so that way it will continue to restart whenever you make a change to the underlying files. So nodemon, so now I can go nodemon server.js. This is app listening on port 5000. And then I'll come in here, refresh, and you see hello world. So the Chrome browser, when you type in a URL here, by default, it is making a GET request. It makes a GET request. Again, requests can have different types: GET request, POST request. A POST request is when you're trying to like send information to the server to, to save. So like if you're signing up on Facebook and you fill out your form, that's going to be a POST request where you send along all that form information to create your user. But then here it's just a GET request. We're not sending any information. We don't care about sending info to the server. We just want to get info from the server. So it's called a GET request. So when you type in a URL in here, by default, it is a GET request. So you might be wondering, this says localhost 5000, and then in our code, it says /. So it's like, well, what does that mean? So I'm just going to copy this down here because I'm going to make another route. So this is everything that comes after localhost 5000, so /. So this, we're specifying routes for everything that comes after the domain. The domain and then like the .com or .eu or .fr or whatever. So yeah, so like for example, so like in reality this would be like facebook.com/. So this is kind of like the home route. This is like the home base route. So some things you can do is you can have this send HTML, CSS if you wanted, or you could have another server handle sending HTML, CSS, and then this server is just handling kind of the special requests that happen after they get that HTML, CSS code. But anyway, so let's specify another route and it'll make a little more sense. So we're going to call this one friends. All right. So actually, I haven't had dinner yet. So foods, I'll do that. All right. And then what we'll do is we'll specify a variable. We'll call this const foods. All right, and let's put some different foods in here that sound good. So I love Thai food, Mu Ping. It's like a street food. It's pretty good. I also like Mexican food. I like tinga. It's another like Mexican like street food kind of a thing. I like mangoes too. All right. So there's some different foods. And then in res.send, instead of sending just the string hello world, we're going to send foods, the variable foods back. Okay. So let's go back to, as you can see here, this automatically restarted the server, so I don't have to manually restart it. So we refresh this stays the same. Now let's go to /foods. So localhost 5000, you have foods, and then it returned this array, and it's just rendering it like JSON here in the browser. It's just something that Chrome is doing by default. So localhost 5000 foods, Mu Ping, tinga, mango. And then if you go back into here, again, you see this. So again, this is all just stuff living on the the browser. So actually, here, all right, so let's try this. So let's put, all right, so I'm going to put this array up towards the top up here. And then in foods, we're just going to list the foods. But then there's something else we can do too. Okay, so there's different things you can add on to, well, all right, sorry, I'm thinking of how to structure this example. You know what? I think this is, you know what? We're going to save that for another day. We've been going for 45 minutes, and that's opening up a can of worms for me to dive into that next thing. So, all right. So I think this is plenty for today. So, all right. So import Express. require. We require it. That comes in from the node modules folder. We come down here and then we create an app, this object. Then it has a get method on it. The first argument that you pass into this get method when you invoke it is the path. And then the second argument is the function. So we're saying that when the user makes a get request to this path, then call this function. When they make a get request to this path, call this function. If they make a get request to here, it's only going to call this one. It's not going to call this one. It's just going to call this one. So that's kind of how it works. It's like kind of like this is like we're defining a function, and this is the name of the function right here. Is that URL, and then this is the code that runs. So so this is your first introduction to server code and how to handle HTTP requests. So down the road, what you would do is you'd have requests on here or routes on here. We call this a route. I call this a route. You'd have a route on here that would handle creating a new user or updating different parts of the user. So are the requests the same if you can't write in the ES6? Yes. The only thing that would be different between this file and if you were to be writing this in ES5 would just be that I'll just refactor this. I'll refactor the code. So consts would all be vars. This would be let's see. These would all say function. You need to get rid of the arrow part. Okay, so that's exactly equivalent. You can see that I refresh and it does the same thing. So yeah, I mean, because the ES5 is supported with an ES6. I mean, all this ES6 stuff is being converted down into ES5. Anyway, well, Express is a little different. In the browser it is, but in Express it just interacts natively. But so anyway, this is at least I'm pretty sure it's not compiling it down. Not sure how the underlying code actually works with Express for how it handles ES6 code, but yeah, so that's pretty much So it's you can use both styles. I would highly recommend that you start using ES6 syntax as well. Just because that is the future. That's where everything's headed. And nobody will ever be going back to doing var. Lots of places still use var in that older ES5 code, but everyone will eventually be moving to this ES6 syntax. So that's the future, and that's where you should be going. All right. So there's your first basic API. And then what we're going to do is we're going to start integrating it where you're going to have a server running that's your Node and Express server, and then you're going to have a client server that's running for your React code. And that's the server that serves up your all of your React code and everything all bundled together to the browser. So what will happen is you'll go to like localhost 3000 and you'll get your JavaScript code, you'll get your React application, and then there will be code in there that will talk to your other server that's running on localhost 5000, which is your Node Express server. So you'll have them, it'll mimic a full stack application that's communicating over the internet, but it's all being served and ran locally. So, and this is also like the heart of what we're going to be teaching in our part-time and full-time classes. It's all about Node and Express, React, Redux, sophisticated client-side applications communicating with, sophisticated server-side applications, and that's web development. And learning how to do all this and code all this. This is how you become a pretty solid web developer. All right. Any last questions before we end this? I'll send out some homework in a little bit. All right. Jumpiness from the videos. Okay. Anyone else getting connection issues or jumpiness? Okay. So, all right. Yeah, we'll do what we can to ensure that we have the fastest the fastest upload possible from my end. And then we'll also be recording videos as well, because I mean, stuff happens. We know in our courses that, there will be days where maybe your internet will be down, or, it's, I don't know, some major sporting event. And so everyone is using their internet all at the same time that we're trying to do our lesson. And so maybe your internet will be slower in your area. But, we'll be recording things and making sure that there's, we'll be working individually. That's part of the reason too, why or your roommates are playing video games and hogging the bandwidth. Yep. So, we're going to do what we can to, and, that's part of the reason why we keep our class sizes small as well, is so that way, if something like that happens, at like a really bad time for one of our students, we don't have 50 students that, a couple teachers are trying to manage. It's, it's pretty small class size, so we can make sure that we're working things out with you individually and stuff like that. So awesome. Thanks for helping us test out Zoom today. I think this is the format that we're going to use moving forward. I think this is all going to be a lot better than just trying to do all the Google Hangouts stuff that we were doing before. So the video will not be available for a little while because I have to now upload it to YouTube because we're not streaming it live in that sense. So anyway, so we'll get it up and then post the link shortly. All right, let us know if you have any other questions. Thanks.